Hello everyone, welcome back to this course. In the last session, we successfully set up a basic Express.js project using TypeScript, and we created a couple of routes along with their implementations to understand the fundamentals of Express.js. Today's session is going to be incredibly important because we are going to dive deep into two core concepts that power virtually every real world application in Express.js. And those two core topics are middlewares and error handling. And we shall be implementing or using these two core concepts using the next function in Express.js. We will also briefly look at how to handle different HTTP request methods like get, post, put, patch, delete, etc. Just enough to get you comfortable with Express.js syntax, and some of which we already discussed in our previous lecture as well. So let's begin by understanding what middleware is. In Express.js, a middleware is a function that executes between the request and the response cycle. Think of it as a gatekeeper. Whenever an HTTP request hits your server, it first goes through the middleware functions before it reaches your route handler. And similarly, the response can be processed before it's sent back to the client. Middlewares are powerful because they allow us to do many things, such as intercepting and modifying requests and the responses. They could be used for logging information, for performing authentication, authorization. They could be used for attaching metadata to the request for further process request or for the further process of request. We can also use it for parsing the request bodies, and we could use it for handling the errors gracefully in our Express.js application as well. The middleware function signature always has three arguments. The first one is always the request, that is going to represent the incoming request object. The second is going to be the response, which is going to be the outgoing response object. And the last is going to be the next function. Next is a function that tells Express.js to move to the next middleware or the route handler in the pipeline or in the chain. So let's write one of the middlewares to see this in action. So what we will do is we will navigate to this index.js file of this src folder that is created in a directory called express.ts demo, and we will be adding some code here. And let me quickly show you what code we shall add. So I would say app.use, and here I am going to provide a callback function. And this callback function is going to accept three arguments. The first one is going to be the request. The second one is going to be the response. And the next one is going to be the next function itself. So far we have imported this request response types from Express.js package, but we are yet to import the next function definition. So let me install the next type here as well. And when I will include this next as the argument to this callback function, I shall assign this the type of next function. Now you would have guessed that this is actually a middleware function that we are trying to write here, because it follows the exact same syntax that we just discussed. First argument is request object, second is response object, and third is the next function, which we can make use of in order to transfer the control to the next middleware or the route handler. Now what we are going to do here is let's create a variable, say, called timestamp, and I am going to assign it some value, say new date, and let's convert it into a format so that it is easily readable. So I will convert it into ISO string. The next thing I would do is I would add this console.log statement, and here I am going to log certain things. Okay, the first thing I am going to log is going to be the timestamp. The next thing that I would like to log here is going to be, let's say, the method of the request. That means whether you sent a request with a get method, post method, delete method, etc. And probably one more thing that we can look at is say request.url. Let's look at the URL property as well. That means which path you are trying to visit. Now, please note that I am adding this before any route handlers in my application. If you could take a look here, the route handler for this home endpoint and this about, they are added after this middleware function that I have implemented here. So this middleware is going to execute on every request, and it is going to log the timestamp, the HTTP method, and the requested path. And once it logs this information on the console for us, it is going to pass the control to the next middleware or the request handler using this next function that I am going to use here. All right. So why did we use this app.use here? Because this method attaches the middleware definitions globally. It applies to all the routes that you will ever write in this Express.js application, as long as you write that implementation after this middleware. Okay, so that's why it is important to add it before defining any route handler. And let's try to test this, if this is even working or not. And in order to test that, what I'm going to do is I'm going to start my server. And how do I start my server? Let me first clean this. Console, and I am going to run the dev script. Once I run the dev script, it is going to start a server at port number 8080. Then I shall navigate to this Thunder client extension, and let's say I am going to hit the home endpoint itself. And the moment I hit that, I would show you the console as well as the response string that we get. So if I hit this send button, then you could see that we are getting this response string that is hello from Express and TypeScript app. In addition to that, we are getting some additional information here. One is we are getting the exact timestamp when this request came or arrived at the server. Second is going to be the request method the request came with. And the next or the last one is going to be the path or the requested path. Simply, if I make it get, even though this does not exist, and if I still click on send, though I get this message 404 not found, but I am still getting a log because the middleware function is anyway going to run for every request that arrives at the server. I get the timestamp, I get the request method, I also get the requested path here. Okay, fair enough. So let me quickly collapse this terminal and let's look at something else now. So we know, or we have understood, that we can add middlewares and we can probably log some information. Now let's see how we can use a middleware function that can inject data into the request object, which then can be used by any of the route handlers that are written afterwards. So what I'm going to do is I am going to add a sample route or a sample middleware function implementation here. And for adding that, maybe I would comment it so that we don't have a lot of middleware functions and it is easy to understand for us. So what this middleware function is doing is it is simply creating a new key requested at in the request object. And what it is adding as the value to that key, it is going to add the current date converted into the local string. Now, what happens if I try to use a syntax like this? This will allow me to use this property named requested at in any of my route handlers. Let's try accessing this property in one of our route handlers, and let me try accessing it in the very first route handler that we have here. That is this. So what I am going to do here is, since it is saying hello from Express and TypeScript app, in addition to that, I am going to, let's say, add a message that says request dot requested at. Let me quickly make sure if it is the same attribute. Yeah, it is the same attribute, but we are going to get an error here, or rather a warning from TypeScript. Why? Because it says the requested at property does not exist on type request. Remember that this request parameter that this callback function is receiving is given a type annotation of request type from the Express.js. And this does not have requested add property. This is something that we have added by ourselves, and this is a custom property. So in order to make sure that TypeScript for now does not give us any error, what we are going to do is we are going to tell TypeScript that please treat this request as type of any, and in addition to that, to this rest.send function, what I'm going to do is I am going to create it a template based string, and here at the end I am going to add this. So request as any dot requested add. That means whenever we are going to visit this home endpoint using the post request method, we definitely are going to get this message back, hello from Express and TypeScript app. But what we need to test is that are we also getting this requested add, which was what? Which was an custom property that was added to the request object by one of our middleware functions. So let's go back to Thunder client and let's see if we are able to get that response. The moment I hit the send button, it refuses the connection because we have not started a server. So let me come back and start a server. So the server is up and running. Let me drag it a little bit up and click on send here. And if you look at it here, hello from Express and TypeScript app, in addition to that, we are also getting this time. And if we are able to access this time on the request object, of course, Express.js does not do it by itself. This is something that we have, customly implemented. So that means middlewares or the middleware function that we added, it did run before the request reached the actual route handler, right? So what did we do here is the middleware actually attaches a custom property named requested add to the request object. And this is a very common pattern that we will use going forward in order to pass, say, user info, session data, or even some request metadata through this pipeline of middlewares. Okay. Now, the next thing that we are going to do is what I'm going to do is I'm not going to close this server since we will be making very frequent changes. So I would keep the server up and running. Now, after having seen that a middleware can be used to add some metadata to the request object, we are going to use middleware for some other function this time. And we shall be using it to validate whether a request needs to be entertained or not. So let's write a middleware that only allows access, let's say, if something like, a query parameter like, secret has a value called XYZ or 123. So if a request that is coming in, if it is providing you with a query string, let's say secret, and, a very fixed value, say XYZ or 123, whatever it is, if the request has that, then we are going to process that request. Otherwise, we are not going to process that request. All right. So in order to do that, I am going to add another function here. So if you look at it, what it does is it creates a function here, authenticate. The function is created here and it is later assigned to this authenticate variable. As you can see, what it is doing is it is first trying to get this secret from the query string. And after that, it is checking that if the secret is exactly equals to 123. If it does, then in that case, the request shall be allowed to move forward. And whatever the processing is required for handling that request should be done. But in case this secret is not present or the value is not 123, then we shall be straight away returning the response to be unauthorized access with a status code of 401. But wait, what we have done here is we have created this callback function or a callback like function that also looks like a middleware function, but we have not implemented or used it in our Express.js like the ones that we were doing before. We have not used app.use method here in order to add that middleware function to the pipeline. Instead, what we have done is we have assigned it to some other variable authenticate. Now, what can we do with that variable authenticate? We can make use of it to make any route protected. That is, if we want to perform such a validation only to a selective number of route handlers or only to specific route handlers, then we must not specify any of such middleware functions using the use method. Instead, we have to or we should add this to specific route handlers. For example, let me create another route handler and let me create this get itself. So app.get, I'm going to listen on the home endpoint itself. This is going to say request response. And this is a callback function, which is going to do something. And let's say I am going to return a very simple string. Say you have accessed a protected route. Okay. So this is all I am going to do here. I have created this endpoint, and as soon as the user hit this particular endpoint, then I am going to return this message as the response string. But wait, I have not mentioned this authenticate function anywhere in this route implementation. So how will the Express.js know that this validation has to be applied on this particular route implementation? In order to do that, what we will do is we will pass this authenticate function as an argument between the path and this callback function or the route handler. So what I'm going to do is I am going to add this authenticate here and separate these with a comma once again. Since I left the server running, so I don't need to restart my server once again. And since we are using NodeMon, as soon as we make any small change, the application would be restarted automatically. I will change the request method to get and hit this sync. So as you can see that we are getting a message unauthorized access. And as you might have guessed as well, the reason we are getting this message is because we didn't added the query string that was required in order to access this particular route implementation. Let's see what happens if we add that query param here. So the query param was secret and the value was supposed to be 123. And now if I click on this send here, then this says you have accessed a protected route. So this is how you can even use these middleware functions for performing validations, for performing authentication, and other custom logic that you would want to perform before the request even reaches the actual route handler. Okay, and this is a very simple example of how middleware actually powers authentication and the authorization flows. Even in the applications that we will be building going forward, we shall be implementing our authentication mechanism entirely with the help of such behavior or such implementation only. Now, let's very briefly demonstrate how to define different types of HTTP request. And to do that, we can use the respective HTTP methods. So what I'm going to do is I am going to, let's say on this home endpoint itself, I am going to create certain methods. So this, let me change it to, hello. I will change it to hello. And let me add a few more, implementations here. So one is going to be app.get. And let's say the endpoint is going to be data. And here I am going to add a callback function. Okay. And this callback function, what will it do is it is going to return a very simple string that says received a get request. All right. I am going to copy this and I am going to paste it twice so that I can implement or test different HTTP methods. So data, then get data, post data, and let's say delete data, just for an example. And this I will change with post, and this I will change with delete. As you know, the server is already running. I will come back to the Thunder client and we'll see what happens. This time I have to navigate to the data, and we know that data is not protected by any of the middleware functions. So I would click on send. It says received a get request. If I change this method to post, it says received a post request. If I change it to delete, it says received a delete request. If I change it to put, then such route implementation is not yet defined. So that's why we are going to get 404 not found error in such a scenario if that does not exist. So as you can see, we have added 3 different routes with the same path, but with different HTTP methods. Okay. And we have already tested these behaviors that each of this endpoint with a different request or HTTP request method is emitting a different behavior. Okay. Currently we are using this Thunder client in order to test our application endpoints quite quickly. But there are other dedicated API testing tools that you can also use. There is Insomnia, there is Postman, and you can use any of these utility in order to test your REST APIs. And probably going forward into this course, we might use one of such tools in order to test the implementations of the REST endpoints that we will be implementing right later. So moving on to the next thing, that is error handling. Now error handling is one of the most underrated yet critical parts of backend development, I would say. And let's begin by routing, or instead by writing a route that is going to simulate say a request failure. Okay, so let me come back to this index.ts, and here let's say I am going to write app dot, or instead of creating another route, since we already have a lot of them, I am going to say comment this out, and I will try it out on the home endpoint itself. I have removed this authenticate middleware function. That means it will no more, or it will not look for that secret query string and the value of 123 to that. Now what I am going to do here is I am going to intentionally throw some error. Now how can I do that? Well, that is going to be quite simple. I could create an error like this, new error, and I can pass any message. Let's say something went wrong. Well, the predetermined message that we have if anything goes wrong. And the next thing that we are going to do here is we are going to call the next function. And sorry, this should be next and not next tick. And we are going to provide the reference to this ERR here. The problem is that we have not included the next argument. So let me quickly include the next argument here, and we'll also annotate it with the next function. Now, what I have done is I have explicitly created an error. And what I did is I passed that error into the pipeline of this middleware or route handlers. So what will happen is you will require some route handler which is going to take care of this particular error that you are emitting from here. And let's see what happens if you will try to navigate to such a route when you don't have any such mechanism in place which is going to tackle that for you. So let me come here and hit the home endpoint and click on send button. Okay, looks like I have done it at okay, I have made the request method put. Let me make it get and click on send button. And here this time you can see that it says 500 internal server error. That means our application has crashed. If I come back to my terminal, you would be able to see the logs that the application would have been crashed by now. We can see the application is crashed. And this is something that you would not want to do or see in your production servers, right? So what is the solution to that? The solution is that we add a middleware function that is explicitly going to catch all these unexpected errors. And let me quickly add such a middleware function. Now, I am going to add this middleware function at the bottom. The reason I'm adding it at the bottom is so that it would be able to catch the errors that come in from any of the routes that we have added in our Express.js application. If you will add it in between, then the routes that you have implemented after defining this middleware may not be covered. So that is why it is better that if we put this middleware definition at the end of all the routes in our Express.js application. So if you will look at it, what does it do is it accepts 4 arguments. The callback function that we are providing to app.use this time. Now app.use again means we are globally adding this middleware function. That means if you will call next function on any of the middleware functions or the request handler and do not return the response, then the request will come here and will be handled. The very first argument is the error. The next is request, response, and the next function. And what are we doing here is we are simply logging the message, the error message, and we are returning 500 status code to the requesting client. We are returning the status of 500, but this does not mean that our server has crashed. That means we will not see that long trail of chain of errors that we saw before in the terminal. That was because our application broke. We were not handling that error at that point of time. But now that we have added this middleware function, our application will not crash, though we are also going to get a meaningful error message this time. So if I come back here and say hit the same send button, so this time you could see we did get the 500 internal server error message, but the response that we got is quite formatted this time. It says status is error and message was something went wrong. And if I will come back to the terminal, though we have printed this error message, that is why we will be able to see this log that will say error, something went wrong. We didn't get this long chain or this trail of error description or the message, because previously our application was crashed, and this time we have explicitly handled that error and we didn't let our application crash this time. Okay. So this is a simple example of how one can define a global error handling middleware. Remember, this needs to be done at the end of all the route implementations, so that any unexpected route is not left, and this should be applicable to each and every route that exists in this application. So let's quickly summarize how the middleware chain works. As we have already tested quite a lot of different definitions or use cases of middlewares in the today's lecture. So every incoming request passes through the middleware pipeline from top to the bottom in the order they were declared. That means if any middleware is declared first and some middleware is declared afterwards, then the one that is declared first will be the one that will be executed first whenever a request arrives at the server. Each middleware can either pass control to the next middleware or the route handler using the next function. We have already seen that. Or they could respond and end that cycle there itself. For example, if your request reaches one of the request handler, let's say this about, and here you are sending the response back to the requesting client saying this is about page. In that case, the control will not enter to this middleware function, right? Because you didn't call next function and you already responded to the client with this rest.send function call here. Okay, that we have already talked about. So to wrap this up, let's briefly look at some real world use cases of having or implementing middleware functions. One thing is going to be the logging and the monitoring. We could use tools like Morgan. Other important thing that we have also seen a demo for in the today's lecture itself is authentication or the session management. Middlewares can extract some information from the request or probably from the request headers as well. It can validate them, verify them, and can even attach some extra metadata to the request object that can later be accessed at the respective route handlers. Request validation, we can validate incoming data and reject bad request even early. We could also implement rate limiting, which is also known as throttling. That means we can limit the number of requests that a user can make in a fixed amount of time. We could also use middleware functions for probably adding custom headers in the response, or even for implementing cost checks. And of course, we can use middleware functions for the analytics purpose for usage metrics, like page views, etc., etc. So all of these are made possible by the flexible middleware architecture of Express.js. So to summarize what we did in the lecture today, we understood what middlewares are and how they are the backbone of Express applications. We wrote multiple middlewares for logging data. We also did some data injection that was we tried adding property to the request object that we were accessing later in one of the request handlers, later into the pipeline. Conditional access, just like we added that, secret query string with a fixed value of 123. And we also briefly saw that how can we handle different types of HTTP request methods in a simple Express.js application. And at the end, we also implemented a centralized error handler, using app.use and the next function. So this is going to give you a solid foundation to build real world web servers with the proper error handling and modular logic as well. In the upcoming lectures, we will look into modularizing routes using Express.js routers, which we have not used so far, and later on integrating environment variables, templating engines, and even database connectivity. So that's all for this lecture, and thanks for watching.